In this video, I will be going over how to set up your CNC machine for CNC-RP and how to run your first part. The first step to using CNC-RP is to start your CNC machine, in our case, the VF2SS. To start the VF2, first make sure the emergency stop is disengaged by turning it clockwise and then hearing it pop up. Then hit the green power up button to start the machine. You should see this screen after waiting for the machine to start up. You are going to want to clear any errors you see upon starting the CNC machine. To do this, click the reset button. If any errors remain after clicking the reset button, I would ask an expert nearby for help. In our case, that would be our head lab technician. Once you have reset all the errors, make sure to click the power up restart button. This button will zero the CNC's coordinates and allows CNC-RP to be used. Before starting any part, it's important to make sure an expert has set up the CNC machine ahead of time to meet CNC-RP's requirements. There is a further video looking into that as well. It is also important to make sure your CNC machine accurately matches the information you used in the machine library, as well as having tools matching that of your tool library. Before starting a part, it's important for your CNC machine to be warmed up. In the VF2 case, if the machine is idle for more than 4 days, we like to use the warm-up cycle. The VF2 will automatically show this code upon starting the machine. If you do not see the code, simply click the memory button. When running the warm-up code, it's best practice to have a short tool in the spindle. If there is a long tool, like in our case, we are going to need to perform a tool change. To do so, first close the doors, then reduce the rapid speed to 25%. Next, hit the MDI button. Lastly, find a short tool, in our case, a 3/8 inch ball mill, and locate its tool number, in this case T8. Then type T8 into the CNC machine. Next, we are going to use the ACT button to perform a tool change. Before we hit the ACT button, make sure your hand is on the feed hold button in case anything goes wrong. Then, hit the ACT forward button to see our tool change to its 3/8 tool. Now that we have a shorter tool in place, hit the memory button. This will bring us back to our warm-up program. Next, hit the green cycle start button and leave the machine to work through its 20-minute warm-up. After hitting the power up reset button and warming the CNC machine up, we are now ready to insert our stock material. To do this, we must gather our stock material. When gathering your stock material, make sure your stock length and stock diameter match your CNC-RP setup sheet. Once you have gotten your stock material, move your work table so that you can easily reach both jaw chucks. To do this, first find the MDI button and click it. Then find the handle jog button and click that. By doing so, we can now control the work table inside the VF2 using the crankshaft. Make sure to hit the 0.01 button so that when we move the work table, it only moves by a small amount. This helps us be safe and make sure we don't ram the work table into anything on accident. Next, hit the direction you want to move in, X, Y, or Z. Now the work table will move in that direction once the crank is turned. I always like to turn the crank a little bit to make sure I'm moving in the direction I intended. You can either just watch the work table or look at the coordinate values on the CNC screen to tell you which way you're moving. Once you move the work table in the correct direction, move it to the full middle of the CNC machine so that you can reach both chucks. Once that's done, open the doors and look at the distance in between the two chucks. If the stock material doesn't have enough room to fit in between the jaw chucks, grab yourself a 13mm wrench and use it to loosen the bolt on the right chuck near the rail it slides on. You do not need to loosen it very much, but once done, you can push the right jaw chuck until the gap is big enough for the stock material to fit. Make sure you only ever move the right jaw chuck, as the left jaw chuck should never be moved to preserve the G54 axis. If you do end up moving that left jaw chuck, there is a good chance the program will crash. Next, find a tape measure and measure 1 inch in from both of the edges of your stock material. Leave a small marking there for you to reference. Now, take your chuck key and widen the left jaw chuck until there is enough space for the stock material to fit into it. Then take your stock material and place it 1 inch into the jaw chuck using their previous marking for reference. Then retighten the left jaw chuck until it's holding the stock material. Now move to the right jaw chuck and move it in until it is also holding the stock material by about an inch. Then tighten your right jaw chuck. Lastly, tighten the bolt with your 13mm wrench to make sure your right jaw chuck does not move during the operation. Now, grab a tape measure and measure the distance in between your left and right jaw chuck. With that distance, reference your setup sheet and look for the minimum distance between jaw chucks. Make sure the actual distance between your jaw chucks is greater than this distance. If the jaw chucks are closer than this minimum distance, CNC-RP will crash the machine. If that is correct, our next step is to double check that we have tightened all the jaw chucks down and tighten that right jaw chuck down to the work table. Then remeasure the distance in between the two jaw chucks and make sure that once again it is above the minimum distance. Once we have finished our rechecks, the stock material is ready to go and we can move on to checking our tools. Checking your tooling before every run is an important way to ensure CNC-RP will work properly. First, find your CNC-RP setup sheet and reference the last page, right under the Tool Selection Information heading. Here you can see all the tools that are going to be used for this part. We are going to start by checking the first tool on our list, which is hogging tool number 1. If a tool you are looking for is not in your CNC machine spindle, hit the MDI button. Then type T and then the tool number you would like to switch to. In our case, that would be T1. Next, find the ACT forward button. Note that when you click this button, the CNC machine will perform a tool change. Make sure your rapid speed is turned down to 25% and that the doors are fully closed before doing this. You should see the tool change occur and the tool you selected should move into the spindle. After the tool change is finished, open up the doors and check for wear on the tool. Because T1 uses inserts, we treat it slightly differently compared to the rest of the tooling. First, I check each insert for any chipping and replace them where necessary. You can reference the tool maintenance video for more information on how to replace our tooling. Normally, the next step is to touch off our tool and make sure it has the correct height in our CNC machine. But because this is an insert tool, its highest point is not on the center of the tool. This requires a special tool touching process. Once you have finished touching off the tool, put a check mark by it on the setup sheet and move on to the next tool. In our case, that's T8. Follow the same ACT forward process that I showed previously. Check for wear around the cutting edge of each flute. If wear is found, replace the tool. Once you have confirmed the tool is in good shape, it's important to measure it. One of the more costly mistakes in CNC-RP is not meeting the required maximum length of the tool. This will cause material to be left over and could eventually lead to the spindle and tool head being dragged through the base material. This type of crash will also not alert the CNC machine's system, causing it to continue to run, leading to even more damage. To avoid this, I check the height of my tooling before every part. To do this, I grab a tape measure or ruler. Then make sure to measure from the end of the tool holder to the bottom of your end mill. Do not include the tool holder. Reference the measurement you got with the length listed next to the tool on the setup sheet. If your measurement is equal to or a little over the setup sheet length, you are safe to use the tool. If the tool is a lot larger than CNC-RP's length, it will not crash, but you will experience more chatter than necessary and have a worse surface finish overall. If the measured length is under the specified amount, immediately adjust the tool height to the correct amount. Do not run the program if the tool is too short. This will cause a catastrophic crash, as I mentioned before. After checking the height is correct, we can move on to touching off the tool. It's best practice to touch off your tooling, but it's not always necessary. My rule of thumb is to retouch off any tools that I haven't used recently or a new tool that I have recently changed. The method I'm about to show you is done with the Haas wireless probe. So if you do not have the Haas wireless probe installed on your CNC machine, I would suggest finding a nearby expert to help. In the VS2 case, we can first hit the program button, then move to the VSQ tab. Once there, hit F2 and select the wireless probe. Now scroll down to the tool settings and hit enter. Make sure you select the auto option and then hit enter. Now you should type the tool number you want to touch off. In our case, it would be tool 8. Once you've typed the number 8 in, hit enter again and a window should pop up asking you where to output the code. Select Output to MDI. Now you should see the MDI screen change and your tool number should be located within it. Next, hit the MDI button. Make sure you are at 25% rapid and then hit the cycle start. Keep your hand by the feed hold button so you can react if something goes wrong. Once done, click the offset button and navigate to the tool you just touched off. Check to make sure the offset value looks reasonable. For instance, if you have a part with a 2.75 stick out length, you should be sitting somewhere around 4.5, 5.5 inches. If you see something that's way too low or way too high, retouch off your tool. Once you've confirmed it looks good, move on to the next tool and repeat the process. Do this until you've checked every tool for your part. Once you have finished touching off your tools, you need to go and find a USB-A flash drive. Take that flash drive and download your NC code onto it. Make sure to name your code something you recognize so that you can confirm it's the correct part. Eject your flash drive and take it to the CNC machine. Plug your flash drive into the side of the control panel. We will be running the NC code off of the flash drive, so it's important to keep the flash drive plugged in the entire time. If the flash drive falls out or at any point loses connection with the machine, your code will stop, and you will have to start from the beginning. Once your flash drive is plugged in, click the List Program button. Then move over to your flash drive's name and press Enter. You should now see everything on your flash drive that's NC code. Move down to the correct file and hover over it. Then click the Select Program button. This will move the program into the MDI where it is ready to run. It's best practice to make sure that you have the correct code by comparing the names of the code and the tools used in the program with the setup sheet. The tools used in the program will be displayed at the beginning of your NC code. If everything looks good, you are ready to run your part. Now that we've loaded the stock material and have our NC code ready to go, we can start our part. First, make sure to recheck that both jaw chucks are fully clamped and that the minimum distance between your jaw chucks is greater than or equal to that on the setup sheet. Next, click the 25% rapid button. Make sure your feed and your spindle speed rates are both set to 100%. Click the coolant button to check that all your coolant is running correctly. For the VF2, it can be common for the coolant on the spindle to be turned off. So, if you don't see coolant coming out of the spindle when the coolant button is hit, make sure to turn it back on before starting the part. If this is so, turn the coolant off. Then open the doors and reach up to the right of the spindle. Here, you will see a valve that you can turn on the spindle coolant. Once done, close both the doors and turn the coolant on again to make sure that the spindle coolant is running. Once more, double check that you have the correct NC code for your part. If everything is in order, place your left hand on the cycle start button and your right hand on the feed hold button. Now click the start cycle button. It's important to keep your hand on the feed hold button for a few minutes so that you can stop it if anything goes wrong. The CNC should first change to your hogging tool if it's not already in the spindle. Then it will begin carving out a hogging path. Watch your hogging path very closely to make sure the end mill and the tool holder does not get within half an inch of either jaw chuck. If this does happen, immediately hit the feed hold button and try and diagnose what the problem is. If you follow all of the previous steps correctly, this should be no problem, but it's important to watch out for it just in case. Also listen for any odd sounds or signs the CNC machine is not working properly. If you notice anything, hit the feed hold button and ask an expert nearby for any help. If everything is running smoothly and the hogging path is not close to either jaw chuck, then the program should be good to run till the end. Turn the rapid movement to 50% for the VF2 or 100% for any other machine. Due to the age of the VF2, we like to run it at 50% rapid to avoid our tools being thrown by the tool changer. At this point, you can walk away from the machine and come back once the part is completed. If you have some extra time, I would suggest you watch the part until the first tool change. This will help make sure the tool changes are going well. I also like to come and check on the part once or twice throughout the machining process to make sure everything is running smoothly. Once your part is finished, it is now ready to be taken out of the CNC machine. First, make sure the part is completely done and that your code has stopped running. You will be able to tell this by the control panel showing the start of your NC code on the MDI screen. Next, click the handle jog button and carefully move the work table to the middle of the CNC machine, allowing you to easily access the part. Next, open the doors and loosen the right jaw chuck. Also loosen the right rotary from the work table and slide it backwards away from your part. Then, loosen the left jaw chuck slowly until you can take the finished part out. You can then use a hacksaw or another tool to remove the extra stock material from your part. Grind down the remaining sacrificial supports and your part is complete. After removing your part, it is time to clean the CNC machine. Start by hitting the chip forward button. This will start the chip auger and clean out the chips from the machine. To turn this back off, hit the chip stop button. While that's running, reach up and turn the coolant off to the spindle. Otherwise, the coolant will spray everywhere while you are trying to clean the machine. Next, hit the coolant button to turn the coolant on, and begin thoroughly washing the inside of the machine with the coolant hose. Once you have sprayed the machine down, turn the coolant back off by hitting the coolant button again, and open the coolant on the spindle. Next, grab your air hose and blow any remaining chips off the work table and spindle. Try to make sure that the work table, chucks, spindle, and tool holder are all mostly dry to avoid buildup of rust and other issues. Finally, take a rag and some Windex and clean the inside and outside of the doors. Now that the CNC is clean, make sure the auger is off and close the doors. Next, hit the emergency stop button and power off the machine. Once you have finished cleaning the machine, you are now done using CNC-RP and should have a fully finished part.